And we're back. What if I tell you let's do the same formula again, but we're going to make iron 2 oxide. So iron plus O2. Do you really need me to draw this? Plus 2, minus 2, that's iron 2 oxide. Okay? So, we need a 2 here because of the 2 there. Once again, there's a certain percentage of you that are going to want to put a 2 down there. No, it's already been made. It's like adding another tail on a dog. It's just going to look weird. Got to take 2 scoops of this now to have your 2 oxygens. But to have 2 oxygens forces you to have 2 irons. Ta-da! This one's easier. If I gave you the iron 3 oxide, I don't like you very much. If I give you this one, I like you more. Okay? Now, let's look at something that's really practical. This is the methane in your house, natural gas. I just waved my hands in front of the screen like you could see it. That's why there was that pause when I went, this. This is the natural gas in your world. This is what your hot water tank in your home furnace should be doing right now. First thing we want to do is check our atom counts. So we look. On the left side, we got a C. On the right side, we got a C. So as far as I can see, the C's are okay. Oh, but the H's. We got a little bit of a problem here. We got 2 H's there and 4 H's over there. And I know there's still a certain percentage if you want to put a 4 there. And it's just, the package is made. H2O exists. H4O doesn't. So we're going to have to make more waters. Now we got 2 pair of hydrogens on this water. And we got 4 over here. But of course, since we made the whole water extra, it's, accumulating more oxygens. So this leaves us with 1 letter left. O. Uh-oh. O2. Oh, 2 O's and 2 waters. And 2 there. 1, 2, 3, 4. How am I going to fix that? There are 4 oxygens on the right and only 2 there. You going to change that to a 4? You're thinking about it, aren't you? Don't tamper with the loot bags. Take 2 of them now. 1 scoop of methane, 2 scoops of oxygen, and you make 2 waters and some carbon dioxide. And the 2 stuttered. Now let's take a look at hydrogen. That's a space shuttle taking off. Hydrogen should be real easy, shouldn't it? Look at our O's. Uh-oh. O2. O. What are we going to do? I know you want to still put a 2 there. No. There's a loot bag. How many oxygen do you have? How many loot bags can you build? You got enough to make 2. 2 waters. But, wait a minute. I'm going to need 2 pairs of hydrogen and I only have 1. You want to change that to 4 still? Come on. Get with the program. 2 scoops of hydrogen, 1 scoop of oxygen, and you can make 2 waters. Now, take a look at these 2 equations now. The burning hydrogen, the burning of methane. Hydrogen burns nice and clean. Okay? Methane, not necessarily so. It's supposed to make carbon dioxide when it burns. But if there isn't enough oxygen, it may make carbon monoxide, and it can even make carbon. And then the flame is yellow and sooty, and that's kind of why I put a yellow background here. So we have a problem with the burning of methane. If we don't add enough air, we're going to get nasty stuff in there. If we get a nice clear blue flame, then the burn is well oxygenated and combustion is complete. Hydrogen fire cannot be smoky because it doesn't have any carbon. It can only be steamy. All right, so if you see yellow sooty flame, it is not hydrogen. Both fuels will release water vapor. It will be visible in cold weather. It can be felt as humidity or seen as condensation, interpreted as chemical trails by the government trying to brainwash you if you are gullible beyond belief. Okay? We're concerned with this. Now, if we don't get even less oxygen, then it's possible to release unburned fuel. But we're not going to get there, right? But obviously, if you starve an engine of so much oxygen, there's unburned fuel going out the exhaust. What a waste. So let's keep the fire oxygenated enough to make water, and we'll just focus on the sooty stuff here. Now, from what I just told you, this is the Darvaza Grass crater in Kazakhstan. When they were drilling for oil about 50 years ago, Russian engineers hit gas. They decided, well, let's just set fire to it and burn the gas off, and then we can keep on drilling for oil. I was in diapers when they did that. It's kind of not worked out. So, from what I just showed you, you looking at methane or you looking at hydrogen burning? You tell me. Now, here are two that you don't have to be able to do. These are extras. These are going over the top. But propane, it's fairly important to know about. Butane, I mean, are you smoking anymore? We don't use butane for much. So when we take a look at this one, propane, we want to balance it. Got 3 on this side. So what the heck? I'll try a 3 here. Then I'm going to advance to my hydrogens. I got 8 here. I got 2 here. I know he's going to get mad if I tamper with this number. So how do I make 8 and 2 meet on 4? Okay, now we move on to oxygen. And if we do the count, there's 4 oxygens here, 3 pair there. That makes 5 pair. Hey, propane wasn't too hard to balance. Let's try butane. 4 C's on the left, 1 C on the right. So we'll put a 4 there. 10 hydrogens there, 2 on the other side. 2 times what equals 10? 5. Okay, let's count our oxygens. 4 pair on the right. That's 8 plus 5 in the middle. That's 13, and what the heck? 6.5 O2s. You're going to run into these where you go like, it's supposed to come as pairs, but there's no multiple of 2 that adds up to 13. Well, in those situations, you just double everything. And I promise I will never, ever ask you to do butane on a test. But butane takes a lot of air. If you can do butane, then you're totally good for grade 11 and 12 chemistry. But I would promise you I will never, 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 never ask you to balance butane. Now let's look at all of them and see if we can justify why we do balancing of equations. It's mostly these two we're interested in, methane and propane, because they power our world and they can be quite dangerous if misused. There's not too much hydrogen in use. I wish we'd use it more, but it just hasn't caught on. Should we burn these gases and not adjust the airflow as we move to bigger hydrocarbons, we will get incomplete combustion and die. Is that a good enough reason to balance these equations for you? No. Oh, yeah. And matter is neither created or destroyed. It's all conserved unless you are the Hulk. And, he shouldn't be getting matter from anywhere unless he's like a puffer fish or something. But anyway, if you decide to burn these two gases, you got to provide wildly different oxygen levels to completely combust them. And if you don't understand what incompletion combustion looks like, go see my videos. So this would be the equation for your natural gas stove in your house. This would be the equation for a propane barbecue. And occasionally, someone wants to convert a barbecue from propane to natural gas, or a furnace, or a hot water tank. Okay, so let's suppose you've got a natural gas barbecue and you want to switch it to propane. What we have to look at is this. Propane needs 2.5 times more oxygen than methane does. Or another way of looking at this is if we keep a fixed air opening, which is typical. The air intake is frozen, unlike the Bunsen burner where we can regulate both the air intake and the gas intake. On most of our appliances, you can only change the gas intake. So if you can't run up the oxygen to 2.5 times bigger, you cut the fuel by 2.5. So if we want to switch natural gas to propane, you have to shrink the airflow by